thank you so much to Susan and Sarah and Dave and ESEP for giving us this opportunity to act on our long-standing collaboration and come to you for help and to provide information about an innovation program activity at OGC. So I put down this title of Rapid Indicator Collaboration Workshop. Now, OGC has been running activities addressing disaster and emergency management for a long time, and our newest iteration of that is the Disaster Pilot 2021. So I want to talk a little bit about what OGC is for some of you that may not be up to speed on that, and then about what we're trying to do in the disaster pilot, who's involved in it, and some particular issues or challenges that we want to address. These events, being limited in scope and funding and time, have to focus on something. And so some of these events are very broad. Here is our 15 types of hazards. What are some elements of working to address each of those? And some of them try to be a little deeper, to look at small number of cases, but really look at in detail and particularly technically, what are the interoperability challenges? And of course, being OGC, we like to see how standards can address those interoperability challenges and get the data flowing. So let me go on. So I'm going to just give you a welcome and a background of disaster management activities at OGC, motivation and goals of the disaster pilot, and some of the data sharing challenges that's brought up. Give you an outline of the pilot, what we're going to do and when we're going to do it, and bring up a couple of the concepts that we're really going to work on. One of those is looking at different types and roles of data, specifically analysis-ready data, decision-ready indicators, and we'll get into what those are. How we get to the scale of data that's appropriate to the scale of disasters that we are seeing by a paradigm called applications to the data, and another paradigm called indicators to the people. And what this comes around to in terms of using technology and organizations to foster the collaboration over that information is something I'm calling the disaster test kitchen, because it really is about starting with recipes for useful, ready information, but then involving the stakeholders who really can make those better and make use of them. So we'll talk about stakeholders and engagement, and there'll be opportunities to participate in a poll, and perhaps if there's time and interest, we'll do some breakouts for the specific hazard type indicators that the pilot is going to work on, has already started working on. So the quick blurb, what is OGC? And many of you are OGC members. You're participating in OGC activities on your own, in your organizations with ESEP, but it's a number of things. And I think that's the thing to point out. So we focus on that sharing of geospatial information, findable, accessible, interoperable, and reusable, but standards development is only one of the activities that by which we pursue that mission. So we do develop, approve, and publish international standards for the modeling and coding and interfaces to geospatial information. But there's a number of other ways in which we help. One of them is something called a convening authority. We can say, this is an important issue. Let's get people together and see how to address it. Some of it is innovation. So I myself am a director of programs at something called the Innovation Program, and I call it the What If Program. It's where we ask that question: what if there was a standard, or what if we applied a standard that exists to this other situation? What would be the outcome? What are the challenges? What are the actions to make that sharing of data effective and relevant to that situation? And that includes test beds, includes pilots, sprints, hackathons, interoperability experiments, a number of levels of maturity and roles and involvement and time and scope, but they all ask that what if question. Another thing that OGC does is to create these collaborations over issues of interoperability and sharing of spatial information. And ESIP is one of the principal organizations that we have those long-standing and active, vital collaborations with. So there are a few members of OGC, pretty much everyone that you've ever heard of working with geospatial data. 520 of them so far. And it's important to understand that they're actually kind of divided almost in three between commercial, government, and research, academia, non-governmental organizations. So all of the parties to these collection and discovery and provision and exploitation of geospatial information of all types are in the community to participate. What do we do? There are many of different standards, and this is not even up to date. There's a whole bunch more, but every aspect, as I said, it kind of falls into three categories. One category are the models and the semantically rich expressions of concepts which are geospatial or geospatially enabled and really leverage the principle that everything is somewhere. And in almost all cases, where that somewhere is matters to the essence or the relevance or the usefulness. So you have to physically, well, by physically, I mean digitally as well, be able to exchange information. And so encodings such as GML and JSON and SensorML and many of these encodings of information are as important as the model to actually be able to exchange information. But the important part of this sharing across different communities, organizations, systems is that the details of those arrangements don't have to be determining. And so that involves interfaces, services, leveraging the ubiquity of the web. And so a lot of the OGC standards and work has to do with interfaces, APIs, services, ways that information as it's modeled and encoded can then be exchanged between systems and communities without every time having to go into every detail of the operation of both exchanging systems just to have a conversation. Okay. So this is some of what OGC does, and we're going to talk particularly about how they relate to aspects of disaster and emergency management. And I asked Dave Jones if he could pitch in a bit about those activities in ESIP, specifically the ESIP disaster cluster.
Okay, thanks, Josh. I really appreciate the opportunity to talk a little bit about the disasters lifecycle cluster. And those of you that are in here for this session may already have attended the session that we had on Monday. I'm not going to go through all that stuff. I just have a few slides just to give a little bit of an overview. So I will go ahead and share these, but while I'm working on sharing my slides, we have two poll questions for you. And Susan is manning the poll system on Slido. And Susan, I'm not sure if you'll put the link in the chat, or maybe you already have, but we have two questions because this OGC disasters pilot is addressing these terms that Josh talked about. One of them is analysis ready data. We've talked about that in a lot of other ESIP sessions as well. And decision ready information, DRI. And so we have a poll just to gather what your thoughts are. The first one is, and let's see, I think the poll is right there in the chat. So if you click on that and you can answer that question, the question that loads up, and my Slido poll is loading up. How do you define analysis ready data? And it just could be any way that you think. You may have never heard of this term before. You may be spending all your working hours on this term, but please enter in what you're thinking, and then press send, and you can put in more than one answer as well. So analysis ready data. And then the second one is going to be decision ready information. I'm going to look at my slides and then load this up here and share my screen. Okay. So here we go. A lot of lines on this particular slide here, but what I just wanted to talk about quickly is the ESIP ecosystem of innovation that have been evolving over the last couple of years within the disaster lifecycle cluster, where there are a lot of clusters within ESIP. These are just a few examples: discovery cluster, community resilience, public-private partnership cluster, the drone cluster, ag and climate cluster. So we're looking at cross sector or cross cluster fertilization, if you will, so we can really dive into some of the key things that other clusters are doing that might have relevance to decision making. And so it might be in the form of a widget, it might be in the form of a machine learning or algorithm for AI. It also might be something that has to do with web services. If you have GIS web services and you have a data set saying, hey, I have a data set where, all of the roads where a 4x4 fire truck can work its way through the mountains. Is that a good data set? Well, yeah, we could test something like that. So that goes into the disaster lifecycle cluster. And then we have these fingers that are out into existing customers and users today. So the All Hazards Consortium, which has 45,000 members, which consists of state emergency managers, transportation, communication, health-related sectors, also the utility sector. So we can take some of these products and put them right in front of these decision makers and get pretty rapid feedback. DHS, the state of Florida, the Weather Service. So what I did is I took this diagram while Josh was talking and kind of morphed it into the disasters pilot 2021. And this is kind of like how you can think of it. You have OGC partners that are participating in the pilot. You have sponsors that are participating in the pilot and also giving us great, feedback and direction. They may have data and services. As a matter of fact, a lot of challenges that we're seeing are that there's too much data and not enough services. And so we're trying to identify those and see how we can, in our case, share them across different platforms and really increase the amount of situational awareness and decision making. But there are others related to standards, related to things like geopackages. How can we put data in there and then get that off so people can work with data when they're on site in the disaster area where they have no bandwidth and stuff like that. There's also other applications dealing with these. All of these deal with the main topics, which are right down here below: landslides, flooding, and health pandemic related data sets and information. And so the sponsors here consist of NRCan, the Natural Resources for Canada and Manitoba, and NASA, and also there are other sponsors like the in Peru, the CONIDA, which is the Peruvian Space Agency. They have a satellite, PeruSat-1. Who knew that, right? We just found that out when this pilot kicked off, and it's really exciting that they're actually taking imagery and really want further information on how they can share that and engage more people. So that's it for the pilot. And I just wanted to say that we're also evolving in the disaster lifecycle cluster, these ORL levels, these operational readiness levels. What are they? It's really an operational readiness level indicator for the trust level of data that a non-technical expert, a decision maker, non-technical, can look at and say, this is an ORL1, I can trust it, I'm moving on with my decisions. This is an ORL2, I can trust it, might not be as timely enough, or there might be some things like not enough metadata in there or whatever, but I still trust it. And then ORL3 and ORL4, that might be emerging research data sets that could be applied in a decision-making environment that are could be very useful. And so this is not driven by the disaster lifecycle cluster, it's driven by the private sector, the utilities. The people who have to respond and restore power are saying there's too much data out there. We need to trust it. We don't know where it's coming from. So we really like this, want to help evolve this kind of ranking for data. And DHS, by the way, I was on a telecon just a few hours ago with DHS, and they are very much starting to embrace the idea of ORLs, because within the federal government there, they do not and cannot rank data. But if the private sector is doing it, they want to be a part of it. So that's really exciting. And then the last slide here is that ORLs, how do we think will help? We think it will focus on identifying evolving data sources that many people don't have knowledge of, and identify those in use cases, to include automated intelligence, machine learning, and the cloud in these ORLs. So how quickly can we get it? How are they processed and things like that? We're also working very closely with the data quality cluster within ESIP to include users in the product development lifecycle. There's a concept, right? We want to include users and saying, hey, we're just coming up with this. Do you want to be a part of it? They help refine the product, and voila, when you're ready to launch that product, you have a whole set of users that are excited to use it because they feel like they have some ownership in it. And then provide feedback to the product developers. That's what the ecosystem of innovation is going to be doing. And transition the data services into operations in a phased approach. So the utility sector might decide to use a data set tomorrow. DHS, it might take them a year. You know, NASA might say, hey, that's really great. Let's combine that with some of our data and see how much we can turbocharge that whole family of information. So that's kind of it there. And I'll pass it back to Josh. We're excited to be a part of the disasters pilot with OGC. It's our first one getting involved, so we're really excited. And we can also bring what we've learned there back into the disaster lifecycle cluster and help emerge and evolve things that are happening there. So, Josh?
Hey, Josh and Dave, I did switch the Slido poll to the second question that you had, just so you can get that feedback too.
Great, thanks, Susan. So that second question, please take a look at the Slido poll and answer the question of what do you think decision ready information is? Just whatever your thoughts are, I think would be very, very useful.
And we'll come back to that maybe in about 10 minutes. So
sure,
that will
great.
be a good opportunity. Let's see if I can pull these up again. There. All right. I think I probably messed this up again. So let me restart it. There. I have a nasty habit of sharing the window, which is really a portion of my screen, and then moving the window. But anyway, so a little bit of history here. OGC, in its innovation program, which used to be known as the Interoperability program, way back when, has been looking at interoperability and data sharing and spatial data issues related to disasters and emergencies for a long time. Back in 2001, I think was the first that I became involved in one of these activities that addressed disaster situations, and how the awareness that came of being able to share good spatial, good mapping data between the stakeholders was critical. And there have been any number of these initiatives ever since. Just a short, more recent list was the IMIS IoT pilot, which really looked at characterizing a lot of information from ubiquitous sensors, but also people as sensors in the observations and measurements paradigm to increase the ability to integrate information. So that was a pilot done with DHS, looking at Huntsville, Alabama, actually, as a scenario site. And then in 2020, we've had a number of activities. There was a concept development study to try to look at that set of concepts and the relationships in terms of information interoperability during disasters. In 2020 is also the Smart City Interoperability Reference Architecture, which did a number of things, but one of the things that it did was to carry out a near operational exercise in the city of St. Louis, where we had dozens of first responders tracking their whereabouts, being routed to and from various emergency situations, and navigating both inside and outside of buildings, and utilizing the interoperability of a variety of sensors, but also of information from these responders and public safety people. And then 2020 as well was the previous iteration of the disaster pilot, the disasters resilience pilot, which looked at, I think 13 or 14 different hazard types and tried to look at what was characteristic in preparation and response to each of those different hazards. And really, I think refined the idea that it's all about the right person having the right information at the right time. So that time is when they have to decide or act, and the right information is the information which helps them to do that correctly. So we have this context and history in which to carry out this year's disaster pilot activity. And we also did some preparation in two key areas. So one of the key lessons is that, you know, health events such as pandemics, but also such as asthma epidemics from poor air quality, other events related or not to other disasters of varying timescales and scopes. This is, you know, as important for us to be able to understand and manage as any other disaster. And in fact, it's also a complication. So while we have this tendency to look at individual hazard types and say, what will we do if there's a flood? What will we do if there's an epidemic? We don't so much say, what if during the middle of an epidemic, there's a flood and it causes landslides? How do we deal with all of those? You know, we can't go to rescue people because of the landslides, and we can't get our vehicles to where we can clear the roads because of the floods, and we have to keep everybody safe and apart and continue treating them because of the epidemic. So a theme of this was looking at these individually and also saying, well, what if they're complicating each other? So one of the key challenges is to really be able to exchange health data for many reasons. That even more than some other types of data tends to be balkanized into particular groups. And so the insights that come from bringing that data together are very hard to come by. One of the ways that can be addressed is by applying the concept of spatial data infrastructure to health information as well. So we carried out a concept development study, and there's a report from that study which it's available in draft form, and we hope to publicly release that soon, which really looks at what is the key data and what is the importance of being able to share that data in a compatible form. Data about health status, so patient condition, data about health resources, logistics, the geographic context and units over which it makes sense to summarize health information, and also the interventions that are going on and how they're related both to the health status that they address and the resources and logistics that they require. So that was a contribution to the disaster pilot. The other concept development study focused on a trend which has been developing both inside and outside of OGC, and USGS and European Space Agency and others have been very involved in this, which is the EO cloud, and implementing this concept called applications to the data. So there are two pretty serious limits on really making use of, there we go, Earth observation, particularly space-based information, to help people. One of them is moving the data around, and the other is having sufficient processing power to turn that data into a usable form at the scale of these occurrences and situations that they can be used for. So this was really to look at how and who is practicing this, moving the processing code to the same domain in the cloud computing platforms as the data already is, so that the data can be processed into a more usable and typically more compact form before having to move it. And really looking at, are they ready to do this? Are they practicing this? What are the challenges to their moving to this paradigm where the scale and the speed, as well as the cost of applying EO data to these societal benefits, is more easily managed? So now to the pilot. What is it that we wanted to do? Well, as we were looking at the application, getting data from the satellites to where it can be used on the ground, and particularly where it can be combined with data from the ground, such as health status, we wanted to see what does that value chain really look like? Who's involved? What's their motivation, business, and mission to do that? And particularly to focus on the gaps in that value chain that were identified by people working there. Where did they report that data was flowing just fine and then just stopped in time after time, and disaster after disaster? Particularly, they run into the same roadblocks, the same gaps of administrative procedure, and the same gaps of technical lack of, mainly of capacity to shovel data correctly across those particular gaps. And what are the workflows and services that let various stages of that function efficiently? Now, by some estimates, in many of these disaster and emergency response situations, 80% of the time is spent finding the data, wrangling it, preparing it, cleaning it, getting it into a condition where it can be integrated with other data. And then you spend 20% of the time actually getting some benefit out of that data. And so the key pilot goal is to do better, to ideally switch that proportion, spend only 20% of the time wrangling data so that we can spend the majority of that time actually benefiting from it. And so that involves these improved workflows and services. Now, there's two concepts that we are working with. Now, one of them is quite familiar, at least in the remote sensing community, but also increasingly elsewhere, and that's analysis-ready data. This is actually very relevant to, the geospatial concepts, because very often what we want to do in analyzing data is to integrate it, to bring it together at least into the same view, if not into the same algorithm. That almost always means we need to overlay things which represent the same space and time in order to do that integration. And very often it's pretty unclear how to do that overlay with two data sets, both in terms of, for example, saying which part of the Earth does each represent, and also what properties of the Earth does that represent. So the sort of key beginnings of analysis-ready data are to have data which is spatially and temporally compatible, but also compatible in terms of phenomena, that we know they represent compatible spectral bands and calibrations, so that you can say, okay, this area is covered by this data, that area is covered by that data, and we can compare them because they've treated spectral signatures similarly. Both, for example, implemented the same NDVI algorithm or have comparable elements that way. So that's just a bit of it, but that's preparing and documenting data so that it's ready to use for these purposes. But in most cases, that data is great for experts and analysts and remote sensing scientists. They can put this data together. They know those procedures and then interpret it. And that's not the case for most people who are on the ground trying to take actions and trying to, relieve suffering, mitigate the effects of disasters. They need something which relates directly to the decisions that they need to make. And so we coined the term decision-ready information as the output of analyzing analysis-ready data. But there's another term which we'll get into a bit more. When we started using the term information, a lot of people said, well, after all, what does that mean? But what we really want to do is to indicate how people should act, what decisions they should make, and where and when they should make them. So we've turned more to referring to decision-ready indicators as being that direct terminology. And we'll talk a bit about, what, after all, is the difference between analysis-ready data and decision-ready indicators. They're not necessarily a crystal clear distinction, but it is definitely two areas of organization of information. So we're trying to integrate and transform provider data. So implement a data pipeline that goes from satellites in the sky through cloud computing to people with their mobile devices on the ground, the eyes in the sky to the feet on the ground. How do we do that? We do that partly by identifying these transitions and transformations from into analysis-ready data, into decision-ready indicators, and into usable applications. And a third part of the scope was to ask, how can we help the public? And part of that is that people use the web where they have access to it, even, small access, but they'll search for information. And so, search engines can give you websites, but there's a development of something called structured data, tagged information that you can make available on the web, which search engines can leverage to provide more than just a link to the web page and the first sentence from the page, but can actually summarize the information that web resources is trying to show. And through this and other work that's been done at OGC and elsewhere, we're going to be able to have people search for, my town and get back, current disaster relevant information indicators directly from the search engine with that information. So that's the indicator, and then the direct information, what's a good restaurant? How can I save my life? Be able to do both of those. So because we're trying to go pretty deeply into the processes, the techniques of sharing information, we've focused a bit on 3 hazards and on 3 regions to look at the data sharing for them within. The first 2 the first addresses landslides and flooding hazards together with pandemic impacts within 2 river basins in Peru, the Rimac, which is in the vicinity of Lima, and Piura, which is farther to the north. And Dave mentioned, we're going to work with and help the Peruvian Space Agency and other Peruvian organizations to better, more scalably leverage their observations from PeruSat-1 to do that. The second scenario involves flooding hazards and pandemic impacts within the Red River Basin, which is in Manitoba, Canada, and the basin extends south into north central United States as well. So cross-border situation, but we'll focus on the Canadian part there, where one of the major causes of the flooding is the ice jams and ice breakup. So bit of a different climatic situation from Peru. And then the third one focuses specifically on health data and pandemic response. How can we organize health information, determine where and how it's available, particularly in terms of scale. It's nice to have countrywide, county scale information, but it turns out to be fairly useless for understanding the pandemic and how to respond to it. And we look to mix in some EOD data as well in terms of the signs, direct and indirect, which can be used to fill in some of the blanks of reporting of this health information. So those are the scenarios. The pilot, is sponsored and supported by a whole host of organizations. The principal sponsors are USGS, FGDC, Natural Resources Canada, and NASA. Thank you, Chris Linus. And supporters include the CONIDA, Peruvian Space Agency, Amazon Web Services, AmeriGeo members, Maxar, and a number of others. And I don't want to slight any of the others who are contributing or about to contribute resources and time and energy to the pilot, but I wanted to acknowledge you without covering too large of a list. And the pilot, now having begun, has a number of participants who are contributing largely components or work on some of the documents which will be one of the outcomes of the pilot activity itself. So just a quick look at the schedule for the pilot. We started off in June with a kickoff meeting, and most particularly, we had what I've been calling the indicator workshop last week. That was a 2-day virtual workshop where we tried to really look at what indicators can we draw from EO and other data to address flooding, landslides, and health disasters. And also, how can we characterize and improve the process by which these indicators are created, are developed? And that's the recipe part we'll talk about a bit more. So there is then a whole section in here between July and September, where we go to implement things. We bring massive data sets in cloud environments, run them through processing chains using various configurable processing platforms on the same clouds, and provision the resulting indicators to workers in the field using a packaging technique called GeoPackage, an OGC standard, and mobile applications that are provisioned, discontinuously from APIs that provide that chunk of data so that it can be worked with offline as that's necessary, both utilizing the data and reporting to increase it. So in September, we'll have another workshop and we'll try to look at what we've learned by then in preparation to develop guidance for somewhat underserved communities. So guidance on how data providers, satellite operators, and so on can be ready to feed into one of these data pipelines, their processing ecosystems, and then for users, how they can be ready to make use of it. I was commenting earlier before we got started that we're actually starting to think of another concept, the decision-ready people. So, even if we have predictions of disaster, people need to be ready to prepare for it. And if they're not prepared to understand and act on the information given them, then they might as well not have had that information. So having people that are prepared to act on the indicators that can be provided to them is part of that user guidance that we hope to derive from the pilot. And then there'll be a series of reports and guides, demonstrations, and so on, which we plan to conclude, at least in this phase and scope, by the end of the year. Now, as has actually happened, the mission of OGC to help improve data sharing for disasters, resilience, and management doesn't stop. And so we'll, with fingers crossed, continue another phase next year, may address different aspects of this that we're not able to fully develop during the pilot, such as issues of data quality, issues of other disaster types, issues, for example, of the more thoroughgoing application of artificial intelligence and machine learning, any number of topics. But some of what we'll be doing over the next few months with help from partners such as ESIP is to determine what the priorities should be for, what are the next set of challenges to the data sharing and interoperability. Okay. Let's see. Would this be a good point to ask what the poll results are?
Sure. I dropped those actually into the shared Google Doc. I thought that might be the best way to see them both at the same time. So if you are looking at the shared Google Doc, and I can put that link back in the chat, you can see what that looks like.
I think it's this one here. Yep. Okay. Great. Okay, I'm going to switch to that then, I hope. I think this is it. Yeah, so let's increase the size here. So how do you define analysis ready data? And we're a smallish group here, so I invite people to unmute and make a comment if they want to further explain what it was that they were responding to or to ask a question about this. So analysis ready data, data that is reliable. So that's a good point. So a defined quality of data, quality, completeness, coverage, and so on. Has metadata describing how it was collected, where it is, what tools were used to measure it, lists limitations. So interoperable with community accepted tools. So that's a good point, that ready means ready for use by some tools and communities. So we need to know what those are in order to define what readiness is. Data that does not require my attention in terms of stack temporal information and geolocation problems. Yeah, that's what we were getting at, is can we identify which parts of data refer to the same time and place on Earth? Make it the same bit of the environment that it's describing in a standard format to be easily overlaid, enables data processing experts to use the data, well described. So we have some themes here. Missing values are identified and labeled. Minimal processing required before use. So we have both forward characteristics and backward characteristics. It's analysis ready if it was able to be analyzed with minimal difficulty. Transformed for straightforward use in common analytic tools. Authoritative. So that's another one. So there's one thing to be ready for use, but to say that analysis ready data should also be trust ready data is another bar to clear in terms of, is it the best data, and can you trust the people who collected it to have done things correctly? So metadata is a theme. Usability in certain tools is a theme, but authoritative is also a theme. Data that, because it's authoritative, you have some confidence in the results of the analysis. JSON CSV database are certainly means by which data can be syntactically ready and software compatible. Anyone else? Thoughts on this? So I will mention that we are working pretty closely with CEOS, Committee on Earth Observations, to figure out if we're developing components that provision analysis ready data, we should have some idea of what those are. And they've developed, for example, the Card4L specification for analysis ready data for land, which I think emphasizes that the location, time, and properties of the Earth's surface in particular, and other specifications, for example, for radar, are being developed so that not only different radar sets, but radar and other data sets can be effectively combined in the same analysis or algorithmic processing. So one of the important parts, though, is that analysis ready data really refers to computational analysis. So it's ready to be used in another software tool. So it doesn't necessarily need to, or it's not important necessarily to analysis ready data that it already be, human readable or interpretable. So it is really ready for use by another machine is an important thing. So it may be that part of being ready is that we can import two data sets into a GIS and put them on a map and start working with them. But in order to be human readable, right, still somebody has to go through and perhaps bin and normalize and symbolize, figure out what visually indicates something to the people looking at that data. So that's one of the ways to think about what analysis ready data is and what it is not. necessarily. So certainly there are analysis-ready data sets that are very straightforward for humans to interpret, particularly expert humans. But let's go a little further and ask, what does decision-ready information mean to you? So one is that there is some limit to that expertise or technical aptitude. Shouldn't require a lot of that aptitude or know-how to access or use decision-ready information. And particularly that complex information are integrated into a understandable format that tells, the target audience, particularly non-scientists, how to act or not act. So for example, fire danger levels. In these locations, don't light any fires. In those locations, evacuate. So clear relation to decisions. Information related to a decision I need to make that is up to date and sufficiently comprehensive that I can trust my decision. That's the word trust again. High enough quality to draw a conclusion. Trustworthy, comprehensive, and up to date. So we get a few common terms here. So it's useful. That's the list, right? Trustworthy, comprehensive, so that it includes as much as possible relevant to that decision, right? Because if you have an indicator that says, yeah, there's going to be a lot of rain, but it doesn't tell you where that rain is going to cause inundation, then it's not comprehensive. Or if it says in these two spots, there's going to be inundation and we have nothing to say about these other spots, then it's a little hard to figure out where you're supposed to go under those circumstances. And up to date. So this is a really tricky one. Decision-ready info takes relevant data and incorporates it into a specific use case that decision makers have articulated to solve a key need for data. So this is really important that, that decision-ready information doesn't start with the data. It starts with the decision that people need to make and what could help them to make that. Of course, all of these are a back and forth or iteration. They're true collaborative processes. Enough analysis done to see a trend or draw a conclusion from a trusted enough source. Explanations of what decisions could be made. So an indicator might actually be keyed by the decisions to make for particular values or states. Quality and confidence. Data information summarize the units of analysis important to decision makers. Do this, do that, move people under 20, move people over 60. Information snippets harvested from existing documents that closely matches what is asked of the machine. So this is a little bit different. This is pulling, so information identified, for example, as narrative that is identified as relevant to questions that somebody has. So that's a little bit of a different process, but also is a form of processing to increase relevance. All necessary analysis has been performed and advice is provided that is directly applicable to the decision taken. Simple, authoritative, derived from a data product, but not the product itself, and visually compelling. So there's both something decision specific about an indicator, decision ready indicator, but also that lends itself to visualization. That's an interesting one. It doesn't have to be the case. You can have an indicator that, buzzes when you're in the right place with your cell phone or doesn't, but there's something about the connection between indicators and the visual power of interpretation that is relevant. Graphs and maps from near real-time data, timely data, non-technical decision makers, information converted to the variables that decision makers need. So I think that's an important thing, is that analysis-ready data is data in the attributes and units of the observations. And now if it's a model output, it can be quite removed from, an actual sensing, an actual measurement of a current phenomenon in the world. And yet it is providing value of an observable, calculable property of the world and its constituents. Whereas the decision-ready indicators frequently are in units that are relevant to those actions or decisions. Drive 10 miles. It isn't a characteristic of the environment, it's a characteristic of the decision maker. And so that's that idea of a transformation or conversion in variables, I think, is a really useful one. I'm going to adopt that. Anonymous giraffe. So any other comments or thoughts about analysis ready data and decision ready indicators? Should remind people that it's necessary to unmute in order for us to appreciate those insights. Rich, you must have something to mention about this. All right, well, why don't we continue?
Hey, Josh, I'll just say that as we're going over the list of things that people were putting in, I keep thinking about how we can relate operational readiness levels to decision-ready information. How might that play into that definition? And I'm always very curious as to how the user of data sees these definitions, because you have to be on the same page when you're delivering decision-ready information and they understand what that means for them. So yeah, that sort of user orientation is a really good one, because we think of needing to come up with a forward definition. These are the characteristics of analysis ready data, but really it's been driven by, can you analyze it, and trying to gather the characteristics of data that people and tools find is easy and fast to analyze. And the same thing for decision ready indicators. If we say, well, here is the characteristic of a useful indicator, well, we have to, as some of the respondents certainly noted, know the decision maker and their situation, their use case. What do they need to do or to decide in order to figure out what indicator would actually be useful for them? So we'll go into a little bit more detail of what that formalism or property might be.
I just would say I really appreciate the focus on the user. I did not come from the academic background that so many people in ESIP did, but I've sat in a governor's office as they are trying to analyze information when a major pipeline is down. I have sat with insurance executives when a hurricane is days or hours away from the coast, or after it's gone through and they're trying to mobilize response. And the information that was used in both of those cases had such lower quality than what I see in this community and what our expectations are. And so I love the focus on bringing in the users, because I think that that's really going to inform the perspective a lot.
So, thank you very much, Susan. I think one of the things we're trying to do is to avoid a casting of blame situation. Just because somebody finds that they're not being provided with a useful indicator doesn't mean that the data that went into it was bad data. You don't blame the satellite for not knowing where to evacuate. You look at the process and the recipe for that decision support and say, how can I use what the satellite is giving me better than I did before? So, so I'm going to go back to describing a little bit about the pilot and then swing around to what that means for this whole ARD-DRI business and where we go from there. So one of the things I think we've learned over the years is that there are a lot of aspects, continuing and episodic aspects to emergency management and incident response. They're kind of continuous cycles. There are many aspects of getting ready, acting, reflecting, preparing again, doing better. And those are all important. However, when we're looking at particularly the speed and scale of data sharing as being critical challenges, critical gaps, there are certain stages in these cycles which are dependent on that fast-moving data more than others. So we've pulled out from these various stages 5 particular ones. So there's the preparing in terms of looking at both risk of occurrence and vulnerability of the physical and there's a population and physical parts of the environment, but vulnerability can also be ecological vulnerability, so environmental vulnerability. What harm could a disaster do? And then looking more closely and closely involving things like prediction, monitoring those hazards for occurrence and looking at predictions of threat, when and where are there likelihoods of disaster occurrence. So once you're, in a situation of monitoring, then hopefully you've prepared so that the detection of disaster is reliable and the assessment of severity is accurate. This is, often much harder than it would seem, particularly when situations are involving or in inclement situations. So there was in the last couple of weeks a mapathon in Peru. It was amazing. Thousands of people with heads up digitizing and GPS units mapping aspects like structures that hadn't really been mapped before in many areas of Peru. Well, while they were doing this, there was a landslide, and the people said, well, we have all of these assets, we could go map it, but we have to figure out where the landslide is first. Where is it safe to drive? Is the landslide continuing to advance? Would we have people going in and being cut off? Where exactly is that? And because it was raining, producing the landslide, there was a lot of cloud cover issue as far as using the PeruSat-1 optical imagery, but the ability to task the satellite to do a collection, to process that collection and georeference and rectify and prepare that in terms of identifying, segmenting the landslide area, that would need to have been done certainly within 8 hours to support those. And, that capability was not ready. We're trying to get there. And then next steps are impact awareness, that combination of occurrence and vulnerability. What are the predicted impacts? What are the observed? What are the reported impacts? And then what are the activities in terms of responders coming in, facilities being able and ready to support relief, and in terms of populations being located and being mobile. So these 5 situations and 6 sort of indicator categories are what we're focusing on. The other thing that we're trying to focus on are, who is involved, and this is going back to we're trying to move beyond simply clients and servers and ask who are the people that are involved in interacting with those systems. And so we have a range of 6 personas. There is on the one end data providers, product providers, analysts, and then kind of on the other side, decision makers, responders, and the affected public. And so we want to think about what aspects of this ecosystem they are going to interact with and what their concerns are in terms of working with data, and how any of them can find the resources that they need. And so over here is this registry and search catalogs, and I use the term catalogs because with many organizations, many platforms, there's unlikely to be one universal catalog that everybody can work with and all applications can work with, but there needs to be a capability within this ecosystem that is complete and comprehensive. So this turns to those challenges that I talked about in the beginning, and those are challenges both for the flow of information from satellites but also from the field, right? Both in terms of validating and completing those observations, but particularly because we don't assume that those up here know everything and those down here know nothing, that there actually needs to be these user collaboration loops in which there is feedback and the sharing of needs and requirements and situations so that the provision of data through this pipeline actually has relevance. Now, in talking with people, there were 3 sort of critical, we'll call pivotal points of interoperability, or in often the case, non-interoperability, those gaps in the value chain. One of those is going from data sources to analysis-ready data, ready for analysis and in the hands or in a location accessed by the organizations that are ready to use that. So there are satellite collections, there are satellite archives, there are tasking systems, but connecting that, for example, from an organization that does Earth observation to a relief organization. Very often data stopped right there, both for logistical reasons and for organizational and policy reasons. So it's analysis ready data, which needs to be ready to be provisioned, but also for which the provisions have been made for sharing. The arrangements, a disaster charter, for example, being one context, but under which the instructions for getting into action and requesting and responding quickly have been worked out. So we're looking at this in terms of interfaces, but remember that OGC can work on standards for interfaces to share data. ESIP can work on the technical requirements for doing that. That we need other collaborators to work on the policy and legal and so on aspects of those interfaces operating. The second point of interoperability is really this: how do we process it and get to this decision-ready situation? So that's having the scale and access to the data to do this processing in a rapid manner. And we have orders of magnitude difference in the capabilities of different processes. So data which is being downloaded directly to cloud storage, on which processing occurs in place, which is provided through a web interface, can be ready in minutes literally. In more loosely organized situations, I remember being people in Massachusetts saying, we did a really good job. We managed to conflate new LiDAR data in less than a year. That's not really good for disasters. So this is really about time, but it's also about flexibility. It's about, you have a processing pipeline, but it's not making what we need where we need it this time around. We have a combination of flood and interoperability, and pandemic occurrence. We need to know where there is evacuation space to physically distance, not just pack people in. We have to change the algorithm here, change the recipe. So that's another point of interoperability. And then the third one is practitioners who are in the field and in many places with poor connectivity, right? They can't get through. And so they need help in terms of that connected, disconnected situation. So this particular pilot looking at use of geopackages. So packaging up data which can be transferred, updated in various mechanisms, not just the internet, and then can help people to work offline. And we're also looking at some data-centric methods of facilitating access for each practitioner to just the data of the theme, so the indicators of the theme and locality that they need, and not expose or complicate with everything else. So that is the data flow and interoperability issues that this pilot and its component architecture is trying to address on a technical level. And all through that to implement what we can define as a collaboration loop, where we have field responders, field observers, data providers, and analysts and processors being able to interchange. And I'll talk a little more about this in a second. Here is a picture. This was in the call for participation of that wiring of different components, where we have the sources, we have the analysis ready data, the processing to decision ready indicators, the packaging to field ready applications, and several of the feedback loops, particularly health information and human observations, along with the structured web data publication that I mentioned before. So these are the components that the participants are implementing and will soon be tearing their hair out, figuring out how to have those components interact and produce the data flow of data and the production of useful indicators that we hope to demonstrate. Okay, and we said that there's this collaboration loop, but what that collaboration loop is trying to do is to implement these flows of knowledge here. So we have analysis ready data, we have algorithms and processing that can get us decision ready indicators, but we only get those decision ready indicators if we have the input from the decisions and actions, the signs that guide those decisions, localized and visualizable, that combine with the insight to produce useful indicators. And the indicators fall into a number of different, I think, categories and aspects. So we look at indicators that are indicators of detection of something to act on, or prediction. There's going to be a landslide somewhere in this area in the next 12 hours, 80% chance. And evaluation. This is the extent of the occurrence, extent of the impact, extent of the activity to respond. And we can look at what types of hazards those indicators focus on, what the indication is. And we talked about, those indicator types, and also what aspect of life in the world those indicators are targeting. Look at, I'm going to actually skip this one, come back to it. No, what did I do with, there we go. Okay. So
We have about 10 minutes left, Josh.
all right, thanks. So I should speed up because there's a lot of detail here. So here's an example from the USGS of signs that an observer on the ground would look for to say, there is developing or in progress landsliding. And typically we take some of these things and say, okay, we can't observe everywhere at every time. How can we use Earth observation data, remote sensing data, some in situ sensors and models to reproduce this sort of observation of signs and produce an indicator that says, here is where landslides are happening or are likely to shortly happen, and here's the severity of them. Starting from, here are areas that are at risk, here are areas that present a threat, here are areas that produce severity at this time. And there's a whole sequence or cycle of using indicators, of needing them, of making those observations of signs, designing an indicator, producing it, validating it with on the ground observations, getting it to people, using it for decisions, and then reconsidering. This is the part that often doesn't get done is, well, did that work or would something else work better? Okay. So I wanted to cover two more things, and I hope you're bearing with me. One is this workshop that we had about indicators last week, and then the other is how we're involving as many of those stakeholders as we can to actually see that this collaboration between the data providers, analyzers, and practitioners is actually happening, is actually reflected in the indicators that are being produced. So this workshop, we tried to gather as many stakeholders of various roles as we could and looked at landslides, floods, and inundation hazards, and health indicators. And we looked at sort of two levels of this. One is, what are the recipes that have been developed for indicators that give us various decision-ready insights into these three hazards? And how does that process work anyways? How has it worked? How could it work in the future? Part of that has been reimagining the mapping and analysis center, where stakeholders have all been able to get into a room with, with maps and data sources and go back and forth about, is this helpful? Well, how about that? How about if we made this red and added in information about these resources? Oh, that's pretty good. That's been very effective where it's possible, but getting those people in a room in a timely fashion is often quite difficult. So can we reimagine that in our virtual distributed world? And what policy environment, security concerns, and working partnerships would be needed to see that realized? So that involves who needs to be at the table, and we talked about that a bit, what the existing collaboration methods are, new ideas for indicator recipes and roles, and where to go next. So these are the indicators, hazards, and aspects that I went over before. So we presented people with this and said, what would you put in some of these cells? What for pandemic vulnerability would be a good indicator of a political aspect, social aspect, and so on. Okay, so we went through for 2 days in 3 groups, landslides, flooding, and pandemics groups, and tried to fill some of this in. And we have some spreadsheets that have been developed, and they're available to look at and comment on, but we will continue to improve that method of collaboration to work on these three categories. So here are some of the outcomes. Indicators versus data needs clear definition. Full collaboration is not easy and not common. And a lot of experience and knowledge is available, but it isn't really organized as I showed you there. And the work continues. So I think we found that we assumed that this collaboration between practitioners and providers of data and analysts always happened, but outside of these emergency situations, it's pretty unclear that it does. And so there's work to be done to bring these groups with very different concerns and expertise and so on to actually work on this, central concept of an indicator. How can you contribute? Well, you already have, responding to the poll. As an ESIP partner, I'll be working with Dave and others to come up with joint OGC ESIP activities, such as maybe a sprint or so on, that can pursue some of these as a collaborator, which I'll mention just quickly, or as an observer or a participant in the pilot, and contact me if you'd like more information about that. So we actually are just starting to look at how does this distributed collaboration work. There are a number of possibilities, and we'll be doing some experiments, but I think this is right up ESIP's alley in terms of looking at collaboration tools. I've done lots of work in this area in other contexts that could probably be applied to this collaboration challenge. So last thing, and I apologize that I'm using up the time here, but I hope that you find this information useful. We also realized that we needed to step a little out of the pilot context to really involve some of these stakeholders. And so we have a series of monthly meetings of what we're calling the Stakeholder Community Coordination Group. And this has been coordinated in a great degree by Mark Reichert, who's the emeritus president and CEO of OGC and familiar to many of you, to really bring in some of these stakeholders who don't typically get involved, are very busy, like responding to disasters, but really benefit and can benefit us from a collaboration. So that, as I said, this will be monthly, and we'll start to generate, we hope, some joint activities to really operationalize that collaboration that seems only to occur when the disaster actually strikes. Okay, well, regular meetings and participation in the workshops and so on. So if you're interested, let me know. And it may be that you're associated to an organization which is already participating and it just needs the coordination to do so. That's some of the organizations which have already been invited, and we'll have another session of this next week. I think that's it.
So Josh, we have a minute or two. I just wanted to, as there was a question in the chat from Brian Wee, and he was asking, were the stages in indicator development, require, observe, and design, were they recommended in some study, paper, or work group?
So that's, I think, a synthesis of many things that we've learned and developed, for example, in the disaster resilience concept development study 2 years ago. But I look at it as an organization of quite a lot of existing knowledge. So it's one way of formulating this, but I think it's another way to then go back and say, is this what people were thinking? And is this the best way of representing that thought? So it's not anything already standardized, but we're finding that the development of indicators is not very standardized, and so there is some work that we could do here. And Chris is noting that, yeah, I don't think there's a starting point, right? Because, it's like, customers don't know what they want, right? A first responder on the ground doesn't know what satellite observations can do for them. Somebody needs to provide some suggestions, and the dialogue needs to happen that says, oh, we can find deviated fence lines for you that you could use as evidence of landslide development. Would that be useful? In what form would it be useful for you? And so I think it's not so much where you start as how you develop that conversation. Does that make sense? It's kind of a new idea, I think, in scientific work, but I think it indicates that this is, not just hard science. There's a large element of social science here.
One of the things, Josh, just to see, we're at 3 o'clock, but I just wanted to mention, because we talked about it today in a telecon that I was on, Karen Moe was on as well with the All Hazards Consortium, is that there are many agencies and organizations out there that don't share. Some of them aren't able to unlock their data sets from the confines of their own agency. And when that happens, how do you put that data to work serving decision makers, particularly if the data comes from a federal source, which should be taxpayer funded and should be out there to help people. But some data sets are just too sensitive to release them. So I think that's one of the little, I just call it a speed hump in the road, to say, okay, let's talk to decision makers, find out what they need. And if agencies have it, there is a way to share it, whether it's temporary or whether it's longer term, so we can put that data to use as a strategic asset.
Yeah, we're certainly not going to solve that today, but I think we have two approaches to that in this pilot. One of them is that, there are many arrangements, but those arrangements for sharing often are not flexible enough. They don't tie into this sort of ecosystem in such a way that what's really needed can then be provided to who needs it when the time arises. So, you make these agreements that the disasters overtake. The other is, and this is interesting, I've done this actually for many years, but I don't think we've fully developed its usefulness, is that there may be a prevention of sharing particular source data, but that may not apply to an indicator which is developed from that source data. So there is the opportunity for, the source data and the processing of that source data to lie within the, security confines that are required by a federal agency or other organization, even a commercial organization. But then the product of that, which is a decision indicator, not, sensitive information in the nature of that prohibition, can then be distributed fairly to those who need it. So those are two possibilities for overcoming somewhat that reluctance to share.
Thanks so much for this great session, Josh. I really appreciate you coming in and sharing it with the ESIP community. And we are a little past 3 o'clock, so I'm going to have to wrap it up. But I know that people can get in touch with Josh, or if you have any trouble finding him, we'll happily get you in touch. And we will save the recording up to the ESIP YouTube channel and all the documents as well.
Thank you so much for giving me the opportunity to talk with y'all.